So Fritjof, your latest book is called The Web of Life.
Right.
Can you tell us what that's about and why you chose that title?
Well, the book really is about a new scientific framework to understand the nature of life. I have been interested in that for over 10 years. In my previous book, or one of my previous books, The Turning Point, I presented a critique of the mechanistic worldview and its consequences in biology, in psychology, in economics, in politics, and then proposed a framework based on systems thinking and systems theory, and I called this the systems view of life. That's one chapter of The Turning Point. And over the last 10 years I've been very interested in how this systems view of life developed, and I found out something that I didn't know when I wrote The Turning Point, that a whole new language emerged over the last 20-25 years to deal with complex systems. There are what you could call classical systems theories, the general systems theory of Ludwig von Bertalanffy and the theory of cybernetics that emerged, were developed in the 1940s. And those had a lot of influence on the thinking of managers, of engineers, of strategic planners. So systems engineering, systems management, systems analysis, all these are new fields that arose after these classical systems theories. And then there is a real watershed, and I think this is very important to understand. There's a watershed between those classical systems theories and the newer theories that were developed in the last 25 years. And the watershed, the difference is that the old systems theories didn't have a mathematical language to deal with the complexity of living systems. The newer theories have this mathematical language and are therefore formulated very differently and much more precisely. So what I wanted to do was to provide a synthesis of these newer theories that have emerged over the last few years and decades. And as I was working over many years on this synthesis, and as I explored this in dialogues with the leading scientists who contributed to these developments, I realized more and more that two things: that thinking in terms of patterns is a common characteristic of systems thinking, that systems thinking is contextual thinking, thinking in terms of context, of connectedness, and that when you ask what is the main pattern of living systems, or is there a common pattern that all living systems have in common, it turns out that this is actually so, and the common pattern is the network. And this is why I called the book The Web of Life. Mm-hmm. So the book is an exploration of thinking in terms of patterns, of the network that is inherent in all living systems, the kind of network pattern, and of a synthesis of these new theories that have emerged over the last 25 years. Mm-hmm. And it all adds up to a really new understanding, a new framework for the understanding of the scientific understanding, I should say, of living systems.
Mm-hmm. Now, your first book, The Tao of Physics, was of course on physics.
Right.
And now in your new book, The Web of Life, the emphasis seems to be more on ecology.
That's absolutely right.
Can you say why you've shifted your focus? I mean, you yourself started off as a physicist. Why is it that you've shifted your interest from physics to ecology? Yes. What is it about ecology that's so important for you?
Well, there are many strands that came together, and I have asked myself this question very often. In the Tao of Physics, I presented the worldview of modern physics and compared it to the basic ideas in Eastern religious philosophies and the mystical traditions of Hinduism, Buddhism, Taoism. And I called this view a holistic view, but recently I went back to the book and looked at it and actually found that I also called it an ecological view. Mm-hmm. So I used the term ecological to express the wholeness of a perception of the world, the interrelatedness of everything, the larger context in which we have to see things. I already used the term ecological in that sense. And then when I went on to beyond my own field of physics, to talk to, to people like you, to biologists, to ecologists, to psychologists, anthropologists, economists, and so on, I realized that physics cannot be the overarching framework, because physics deals with the non-living world. And you people, all you scientists who deal with living matter, really deal with different phenomena. So not just your particular field of biology, but also psychology deals with a living human being. Economists deal with a living world of people and organizations who are embedded in natural ecosystems. And so very soon I came to realize that the broader framework is really an ecological framework, and that the source of metaphors can no longer come from physics, but has to come from the life sciences. Because just look around here where we're sitting. Well, we're sitting outside, so everything around us is alive. But look at the world at large. Most of the things we see and that we deal with are living. And so you can't have just those Newtonian pendulums and the Galilean planes where balls roll down as a model for the world at large. The world at large is alive. That's why I call it the web of life. So ecology is really the broadest framework. It deals with the entire living network, and ecology, of course, has these many dimensions, all the way from the politics of ecology, from environmentalism as a grassroots movement, to a view of life that is systemic, and I use the terms ecological and systemic pretty much synonymously, all the way to deep ecology, where it touches the spiritual and religious. So I think an ecological worldview is really the best term to use, and ecology is really the best source of metaphors to describe the world at large. Mm-hmm. And this is, I think, why your work with James Lovelock is so important, because the largest system that we can actually describe coherently in a scientific way, and also maybe the largest system where we have an emotional relationship, is the planet Earth. Mm-hmm. And so it's very important to apply this to Gaia, both theoretically in the Gaia theory, and emotionally in deep ecology, identifying with the planet and mm-hmm. living accordingly.
Right. Now, in your book, you mention a synthesis of ideas.
Right.
Could you tell us something about the synthesis?
Yeah, this has matured really over the years, and Schumacher College has played a crucial role, because when I started, I looked at the newer theories, and let me maybe just mention a few names. I am in the book, I deal with the theory of dissipative structures by Ilya Prigogine. I deal with the theory of hypercycles by Manfred Eigen. I'm not going to describe those. This is just to drop a few names, so to speak. And I deal with the theory of autopoiesis by Umberto Maturana and Francisco Varela, with a very closely related theory of cognition, which is often called the Santiago theory of cognition, with the Gaia theory of James Lovelock and Lynn Margulis, with the kind of theory of complexity that Stuart Kaufman has formulated in terms of binary networks. So I'm dealing with all these theories, and I looked into them over the last 10 years and studied them. And the more I studied them, the more I became surprised and amazed by the fact that most of these people don't talk to each other. That although they know about each other because they're scientists, and so they know what's going on in the scientific field, they don't really talk to each other, and they don't really know about each other's theories in great detail, nor are they very interested. And so I was puzzled by that, and many of these people claim that the essence of understanding life is really their path and their theory. And so I realized that there are two big divisions in scientific thinking about nature or reality or life in general. And those are two divisions, two strands of thought that have gone on through the ages, from the Greek philosophy all the way, at least in European and Western philosophy, throughout natural philosophy and science. And those two strands can be epitomized by two questions. When you see something that you don't understand, you ask, what is it made of? That was the dominant strand, and that was called the study of substance by the Greeks. And it's a study of quantity, a study of constituents, a study of matter, a study of building blocks, and so on. The other study starts from the question, what is its pattern? And this is a study of quality and a study of that requires a more abstract description. The reason why the theorists of the various scientific fields that describe life don't talk to each other is that there is this gap between the study of structure or substance and the study of pattern or quality. And so I began to analyze them from this perspective, and I found that a synthesis of all these theories can be formulated by integrating those two perspectives and by saying they both are needed for the understanding of life. And so what I came down with then is a synthesis that says the structure of a living system is a dissipative structure as described by Prigogine. The pattern of organization is a network pattern of a particular kind, which has been called autopoiesis by Maturana and Varela. And then the link between the two, and here it gets a little difficult and subtle, the link is a process dimension, because in living systems, as biologists have known for centuries, every living form involves processes of metabolism, of production and destruction of building up and dissolving structures, processes of development, processes of evolution. So you cannot understand living structure without understanding process. And so what I found is that you can say that the pattern of organization of a living system is embodied in a particular structure, and this embodiment is a continuous process. So I have actually three elements: pattern, structure, and process, and that's basically the synthesis. So I have a conceptual framework into which I integrate these various theories, and this is a framework that I discovered about 10 years ago and have developed. And again, at Schumacher College in my previous courses, we had all these discussions with students, and I could refine and improve the presentation of this synthesis. And I must say, Stefan, that also your presentation and discussion of the Gaia theory has helped enormously, because in our course here we always have a particular theory that we take sort of as a conceptual laboratory, and then try out all these various questions and say, well, is Gaia a dissipative structure? Is Gaia an autopoietic network? Is it cognitive, intelligent, and so on? So with one theory, we can really try out all these various things. Mm-hmm. So all this has helped me a lot, and now this work is done, and the book is written, and so there'll be further steps, but I don't know yet.
Mm-hmm. Well, just to be a bit provocative, the shift seems to be from looking at the world as a machine to looking at the world as an organism.
Right.
But if we think, say, of the heart in a human being or in an animal,
yes. Yes.
That you can think of as a pump. So then why does it help us to think organismically? Why can't we stick to the machine view? It seems to be so helpful in thinking of how things work.
Yes.
The eye has a lens, for example.
Right.
It has a photoreceptive layer, which is like a film.
Right.
All very mechanistic, all very useful
Right.
for understanding the world.
Yes.
Why do we need organism?
Well, it is of course very attractive to think of these things as machines, and that was the big attraction of the Cartesian framework. When Descartes said animals and plants are just machines, and we'll try how far we can get, there was great excitement around the scientific world, and there were probably also communities, a little like Schumacher College, where this new mechanistic paradigm was explored, which really ran counter to the mainstream, which was the Christian, Aristotelian, medieval way of thinking. And so this was a great excitement, and you can get quite far, but as always with an idea that is sort of narrow and limited, it has great force to focus the mind. But then when you apply it too far, you get into trouble. Well, let's take the heart as an example. The heart, and this was of course the first example where Cartesian mechanism was really successful. The heart does work like a pump, and you can use hydraulics to explain the function of the heart. But the heart is not a pump, and you can see this, for instance, when, now I'm not a doctor, I'm not a biologist, I can't give you the details, you know these much better than I, but say if part of this heart muscle is injured, then the body's immune system will see to it that that injury heals itself. Now, a pump doesn't heal itself. When a rotor blade or something breaks off, it is broken and you have to call in the engineer to fix it. So the pump doesn't heal itself. The heart heals itself. The heart can regenerate its cells. Also, the heart does not stay in the same structure. The cells of the heart, like all bodily cells, are continuously recycled, and there is the flow of metabolism that goes through each cell and nourishes it, so that not only are the cells recycled, each cell dissolves and rebuilds its own structures continuously. So it's obvious that the heart works like a pump, but it is not a pump because there are all these differences. It is a living system. Well, then people, of course, realized that, and then they said, well, the heart is not a machine, it's not a mechanical system, but it still works according to the laws of physics and chemistry. You have to introduce chemistry. That would be the next step, and to say, well, it's not a Cartesian clockwork, but it's a physico-chemical machine. And then you say, but a lot of these processes are coordinated by the nervous system, which has electrical impulses going between the synapses. And so you say, well, it's not just a mechanical chemical machine, it has also electromagnetic aspects. And then people said, well, basically what we mean by saying the heart is a machine is that the laws of physics and chemistry are sufficient to explain the nature of life, biological systems. And then this is the big question, are they sufficient or not? And in the past, in the 1920s and 30s, the vitalists said, no, these laws are not sufficient, we need to add a vital force, a vital principle or vital field. And then the organismic biologists said, we agree with the vitalists that we can't explain life in terms of physics and chemistry, but what we need to add is simply an understanding of patterns of relationships, of organizing relations. And so now the debate between, say, the mechanists and the systems thinkers is whether or not the laws of physics and chemistry are enough. And the great challenge for the mechanists is to explain the wholeness of the organism, the integrative capabilities, also the development, the evolution, and so on. And I just find that the systems view is the more appropriate and more powerful view.
You said that the mechanistic view was seen as limited. It had its sort of limited use. Do you think the same will be said of the systems view in the future?
Well, I thought of that while I was saying it. This same idea. I thought I maybe shouldn't say it. Obviously, it will be limited, but it is much broader than a mechanistic view, because the mechanistic view really goes back to mechanics. And mechanics is a part of physics, of classical physics. So it really goes back to seeing the world as a machine and to using one discipline and one level of description, classical physics, and also then quantum physics and so on, but the mechanistic level of description. The systems view in its very nature is multidisciplinary. So you use knowledge from biology, from psychology, from geology, from economics, from various social sciences, in addition to knowledge from physics and chemistry and biochemistry and so on. So it's a more overarching view. So I think the ecological systems view, ecological/systems view, is not limiting at all. However, the particular kind of framework that I'm presenting in the Web of Life certainly will be outdated, 5 years, not 5 years, 10 years from now, 15 years, 20 years. That's to be expected of a scientific model. And I should say this synthesis is presented only in its outlines, and a lot needs to be filled in.
There's one argument I like from David Abram about the machine thing. He says that if you talk about a machine, then it requires someone to have created it, because machines are made by people.
That's right. Yes.
But yet we can't think of how the universe or Gaia could have been created unless you postulate a God.
And that's right.
But in the systems view, the whole thing creates itself, doesn't it?
Right.
There's self-organization. It creates
that's
itself.
the very essence of the systems view, that you have a self-organization, you have autonomy, that living systems are autonomous, they are influenced by the environment but not determined by the environment. And a lot of very interesting questions come from that. I mean, one of the most fascinating questions is the question of free will, the age-old philosophical dilemma. Are we determined? Are our actions determined, or are we free? What do you think about that? Well, that's a really tricky question.
It's very tricky. I mean, if you look at the scientific, from the scientific side, you look at chaos theory and various mathematical models of self-organization, you see that everything is very carefully determined.
Yes.
We talk about deterministic chaos.
Right.
What happens is you change one of the decimal points way down in a number, and that has unpredictable consequences further downstream. But it's still determined.
Right.
And that makes me feel rather uncomfortable.
Yes.
I don't like that idea. I like to feel that I do have free will.
So do you still feel uncomfortable at this point, or have you come to some
I think I feel uncomfortable, and my conclusion I've got at the moment is that the scientific description is limited. That it can't really answer the question of free will, that it's more a question of introspection, that there an answer may come. The scientific model is limited because, in a way, mathematics is another form of mechanism, in a way. And so mathematical descriptions are limited within their own constraints.
Yes.
Yeah.
Well, I was uncomfortable for a long time, for many years, like you. And as I was doing the research and writing the book, I kept this question in the back of my mind. And it seemed to me, the more I got into it, the more determined things seemed, because apart from the quantum indeterminacy, which is another matter, in living systems and all these theories, whether it's Maturana or Prigogine or Lovelock or whoever, these theories really don't leave any room for anything like freedom. Everything is ordered and determined. But then what really helped me was Maturana's idea of structure determinism, and the idea is basically that yes, a living system is determined in its behavior. So when I get up from here and go out and do something else, and you ask yourself, what's he going to do? Obviously you can't predict it, but what I'm going to do is determined, but it's not determined by an outside force. It's determined by who I am. It is determined by my own structure. This is why Maturana calls it structure determinism. And my own structure, the structure of every living organism, is a record of a previous path of development and evolution. So my behavior is determined by my structure, by my metabolism, by what I had for lunch, but also by my genetic makeup, my inheritance, my cultural inheritance, and all of that. So what I feel then is that I act according to who I am. And that to me is freedom. Although it is determined, but it is my actions are determined by who I am, which means they are autonomous and free. And so I think the problem is that we somehow confuse freedom and disorder. I mean, freedom is not a contradiction to order. Ordered things, which determined is really what that means. There's an order in things, an orchestrated development of things. And so there is this order. Things are not random. But the order that determines the action is an order within the organism, and therefore there's autonomy or freedom. Now, having said that, there's also, of course, the random element that Prigogine talks about when he talks about bifurcation points, that there are certain points of instability. But even there you can say the influences are random only because we don't know them. So we call it random because these are little fluctuations in the environment, noise, so we call it random. But in principle, you know, the world is ordered and determined, but living organisms are not determined by an outside force. So I'm very comfortable with that now.
It sounds like the more history you have, the more constrained you're going to be, because the more rigid a structure you would have become.
Well, what do you mean the more history? I mean,
Well,
we all have a lot of history. I mean, all living organisms have, you know, history of several billion years.
But does it mean that the more experience you have, the more that experience is incorporated into your structure, the less freedom you have, because you're more constrained. You've done certain things and not others, and so your whole pattern of behavior is getting more and more fixed. Or does it mean the opposite? Does it mean that you have a wider
I don't know, but certainly it can mean, it can go both ways.
Yeah.
There are people who are very fluid and flexible, you know, like artists, for instance, who are not rigid at all.
Yeah.
And other people are just, you know, very linear and very rigid. So it can go both ways. And what the difference is, I don't know.
Well, I think that way of looking at it helps, certainly.
Yeah.
So maybe we should move on to the last question, which is about the place of spirit in systems thinking. Or the place of the sacred in systems thinking. So far it's been we've talked about science. We mentioned deep ecology a little bit.
Yes.
But how do you see those things coming into systems thinking?
Well, to me, systems thinking in itself, without the ecological context, would still be an interesting and intellectually stimulating activity, but would be futile. And any broader question, I think, has to be addressed not at systems thinking, but at the broader ecological framework. It reminds me of questions that I often get when I give lectures. I would talk about, in the past especially, about ecology, economics, politics, green politics, and so on. And then people would sometimes ask me, as a physicist, what do you say to the recent decision by the United Nations and so on? In a completely nonsensical question, because physics is not the relevant language or approach to deal with, say, political questions or social questions. And in the same way you could say, you know, as a systems thinker, you know, what do you say about spirituality? Nothing. You know, it's not the appropriate language. As an ecologist, that's a different question, because, you know, as you well know, the deep ecology really is grounded in a spiritual awareness, in an identification with the greater whole, which is sort of the basis of spirituality. And there you can talk about spirituality. So what I can say about this new systems theory is that it is consistent with a spiritual orientation because it is embedded in the larger framework of deep ecology. And I think, but there's another thing also which has fascinated me more recently, and that is when you look at the root of the word spirit, or also the word soul in many ancient languages, then you find that the root is breath. I mean, we have spirit, we have expire and perspire, conspire. All this is as the root spiritus, the Latin root, is breath. And what is meant by spirit is the breath of life. That's the ancient intuition. But if you try to express this now, not in a poetic metaphor, but in scientific language, you can say it's the process of life. And the process of life in this framework that I'm presenting in the book is what is identified with mind and cognition. So that's very close to spirit. So there's something to this ancient intuition that spirit is both the expression of consciousness and the seat of the breath of life, the process of life that keeps everything going. You know, we're all infused by the breath of life, and that's what spirit is. So I find that very beautiful and very consistent with the systems theory.
So that means then that we can consider all living things around us, like the trees around us and the birds around us, as having some sort of consciousness.
I wouldn't say that. Well, that depends very largely how you use the words now. The way I use consciousness is in terms of self-awareness, which is a human quality also in some higher animals, but it involves language and conceptual thinking and all that. So I wouldn't say everything has consciousness, but I would say everything is imbued with spirit, and there is a common planetary spirit that flows through everything. I mean, I can formulate this in scientific language, and we can both work on it and write down some equations that correspond to a mathematical model that would describe that. So this is really very close to systems theory, and yet it's one of the deepest human intuitions.
So for you, it's actually cognition. You talk about cognition, as
right?
Being present in everything.
Right. And cognition is present in everything, so there's an intelligence. You know, every one of these leaves has an inherent intelligence, and spirit, or the breath of life, is a very beautiful metaphor for that.
Would it be there in what we conventionally call the non-living, such as rocks or atmosphere and water?
No, it would not be there, because then you talk about the difference between the living and the non-living. Obviously, when you call something the breath of life, it is not in non-living structures, but then it depends on how you look at those structures. If you look at these rocks as they are here, you know, they don't change, they're not living, they're not breathing, they're not developing or evolving. But if you look at them, you know, within the framework of several million years, then it's another story, because then they're part of the living Gaia system, and they at least participate in life.